In a series of lecture, I shall try to make you familiar with the Fortran programming language. The aim all through on this course of lecture will be to keep the things as simple as possible. That's why I will try to introduce as few concepts as possible, and then we shall try to develop some few simple problems, and then I will finally come to the course material. Before going to the Fortran proper, let me first introduce what is the need of numerical techniques. We know that if we have a function like this x to the power n dx, if it is be integrated from the a to b, then the result is x to the power n plus 1 by n plus 1 integrated from a with the limits this. So this the result is n plus 1 b to the power n plus 1 a to the power n plus 1. This is a known result. If we try to represent it graphically, then the thing is that we have a function f of x is equal to x to the power n. For n is equal to 2 is a parabola. So this is y and this is x. And the curve is of this sort. What we are doing by this integration, we are estimating the area from x is equal to a to b. So if we try to assign a physical meaning to this, the quantity on the right hand side is nothing but the area of the shaded region. Here the function is simple enough so that we can carry out the integration in a closed form. This is analytical problem or exactly solvable problem. Exactly solvable or analytical problem. Well, problem, sometimes people says that the result is known in the closed form. Compare another situation, a similar situation. Only thing is that the integrand is not as simple as this. Rather, the integrand is of this form. And our aim is to find out the area between these two. Again, from x is equal to a to b. The curve between a to b is continuous, and there is it is continuous. So this area under the curve has a definite finite value. It was in this case the result is also finite so long as a, b and n are finite. So the result is finite. The only difference is that we cannot write the integration fx dx for such f in a closed form. We cannot write, but the result is there. What I want to emphasize that the result is a definite one, but it cannot be obtained in such a form. So the problem is not exactly solvable problem or numerical problem. If we consider two bodies interacting with each other, as for example an electron and proton of an hydrogen atom, this two-body interacting system can be solved exactly in classical mechanics and in quantum mechanics. But for a interacting system comprising of more than two bodies cannot be solved exactly either in classical mechanics or in quantum mechanics. As for example, if we consider an helium atom, then the helium atom, even if we consider the alpha particle to be a single particle of doubly charged single particle residing at the center, and there are 2 electrons of the helium atom. So it is a 3-body interacting system. This cannot be solved exactly. So to say, only an isolated hydrogen atom problem, belongs to this category. If we have 2 hydrogen atoms which are close to each other so that they interact with each other, as for the case when a hydrogen molecule is formed, or a single helium atom, all these belongs to this case, this category. So in reality, the exactly solvable problem is very rare. Most of the problem belongs to this numerical class. So the numerical calculation is essential. Now, how to come to the point, how to calculate this area? To find out this area, we in general divide into a large number of strips. In theory, we generally say that it is being divided into n strips and n tends to infinity. But whenever you are going to apply it in reality, one has to take some value of n. Say we take some value, say n is equal to 100. We start the result with n is equal to 100. That is, we divide the interval between a and b into 100 equal steps, and we get a value of the result, value of the integration. So we'll say, let us call it I100, where I is this. It has in actually is the value of this integration when we have divided the interval a and b into n equal interval, so that width of each interval is b minus a upon n. So we first calculate, as the example taken, I100. Then we do not know how good or how bad this value is. In this case, no such question arises, because we know the right hand side exactly. Here we cannot evaluate the right hand side exactly, so we are trying to evaluate the result by some approximate method. So the approximation or goodness of the approximation has to be judged. So what we do, first we do perform the integration with n is equal to 100. Then say we increase the value of n by suitable steps. Say we calculate the value of I with 100, n is equal to 110, and then we take the difference I. If this difference is within the tolerance limit, within my tolerance limit, the tolerance limit has to be set by the user. Say for example, we want to calculate the value of the integral which is correct up to 3rd decimal place. Then we must say that if these two values are same up to 4th decimal place, then we say the result is correct up to 3rd decimal place. If not, then what is to be done? Then we increase n further. That is, we go for the calculation with n is equal to 120 and compare the result between 120 and, if the accuracy level is reached, fine, then otherwise one should go on increasing the n values. So the thing that is coming out, we need to do the same repeated job with the different values of n. In this calculation, no intelligence is needed. Only thing, one has to carry out a boring calculation repeatedly. So such repeated calculation, if one human tries to do it, in most of the cases Due to mistake, some error may be introduced and the result may be erroneous. Instead, we could provide a clear instruction to the computer, who will, as a faithful servant, will execute the entire process for different ends. So we need to feed the instruction to a computer so that it will evaluate the integration for a given end, and we will provide the value of n from outside and the accuracy level and the steps of n. That is to say, we will tell the computer about initial value of n and the change in n delta n and the accuracy level. So what it will do, it will first calculate the integral for ni, and then it will calculate the integral for ni plus delta n. If this value is less than accuracy, okay. If not, then it goes to the next step of calculation, and then again asks the question this. If not, then it comes to this, and if yes, then it says this is the value of the integration. And this iterative process continues. Iterative process continues till the accuracy is achieved. So the point that I am going to mention here, that in most of the problem of real life, the problem cannot be solved exactly, and one has to take help of numerical methods. And since every calculation in numerical method has to be judged from the point of accuracy, which is not at all relevant in the exactly solvable problem. So far the accuracy is concerned, one has to evaluate the same thing with repeated values of some parameter. Here the parameter is n, the number of sub-interval, and we require to judge the value between two successive n values, and such process has to be repeated a large number of times. So this is the main point that I want to emphasize. Now coming to the computer programming. As for you know that a computer understands only binaries. So everything you want to write, tell him or tell a computer, you must tell it in terms of binary. As for the present day practice, a number is represented, a number say a, it is represented by a combination of eight combinations of 0 and 1. This is for a. Whenever we write a from keyboard, actually when the information is given to the machine, it is a is equivalent to this. Think how the task will be if one tries to write Bangladeshi. The situation will be horrible. So it is not possible for common people to instruct the computer in such a way. Rather, the instructions are given to the computer in a language which is very similar to what we generally say in real life, and there is a agency or which is called compiler. The compiler converts the message A into this. So we need not to write this one, we need to write A, and there will be some different codes for capital A. I do not know what is the code for binary code for capital A, but there is definitely there is a code for this. If we consider that what is, if such a string, we have a string of 8 bits, then 255 characters can be written as 8 combinations of zeros and ones. So there is a plenty of things that can be accommodated in a 8-bit length of a character. Now coming to the one generally speaks of high-level language, which generally gives the instruction to the computer in a way that we are habituated with. Say we write small a from the keyboard, and the instruction the corresponding binary instruction will be given to the computer while compiling or assembling. Fortran is such a high-level language. Let me come to Fortran now. First, the thing, what is the origin of this name? Formula translator, which is the origin of the name. From the name, it is clear that this software has been developed for the numerical for the purpose of solving numerical or mathematical problems. Whenever you want to use this, you first need to install a Fortran compiler in your computer. The common free available software is Force 2.0, which works in Windows. And if one uses Linux, then Linux, there is inbuilt Fortran software. Inbuilt software in Fortran, in Linux there is inbuilt software for Fortran. So in Force 2, I am confining my discussion to Windows platform. That is, whenever Force icon appears on your computer desktop, you just click on it, and we will find a two-dimensional representation will come on the screen. In terms of matrix, we call it row, and these are the rows, first row, second row, these are the columns. In computer language, we call it rows, we call it not row but line, and these are the columns. This is the screen that will appear when you open a file in any editor, not necessarily a Fortran editor. Even if you open a file in MS Word, such a thing will appear. And in general, on the right bottom corner, the line number and column number are displayed. As you move the cursor towards the light, the column number changes, and as you enter, the line number will change. If doc file, say if you have a doc file, chem dot doc or docs, this is the extension. In Fortran, the general extension is .f, .4, etc. F90, F95, etc. Whenever you want to write something and save it, you go to the file option, and then you will have a save option, save or save as. If you already working with an existing file, then you go for save, and if you want to create a new file, then save as. And save, in the save as part, you need to specify only the name. The extension will be fixed as per the software. You need not to write chem.docs, you need to write only chem, and the extension comes out from the MS Office editor. Similarly, whenever you are working with Fortran editor, the extension will be fixed by the particular editor. So I understand that it is now clear how to open a file and to save a file. Once the file has been opened, file is opened, you will have a screen which we call the line and column. I am confining my discussion to Fortran 77. Fortran 77. So in Fortran 77, one writes the program from 7th column onwards, 7th onwards, and it continues up to 82. The space in between, the Fortran command has to be written between 7 to 82 columns, and these 6 columns are preserved for specific uses that I will go on telling you with time. First thing is to how to write numerals. Numerals are very easy. If you want to write 23, it is simply 2 and 3. You write it in decimal, the computer will convert it into corresponding, or compiler will convert it into the corresponding binary. So when we need not to write horrible things on keyboard. Let us consider the simplest problem. We want to calculate a plus b is equal to c if a is equal to 1, b is equal to 5. What is c? This is the basic question. So first thing is that if we like to change the value of a and b from outside, then we first assign two variables or Fortran variables, a, b, and three variables, a, b, and c. First, let me clarify what is meant by variables and constants. Constants are these. Fortran constants. Constants are 1, 1.9, etc. They are the constants. And variables, small a, capital A, C, etc. These are the variables. Note that in Fortran, small a is equivalent to capital A. In Fortran language, the lowercase and uppercase variables are the same. If you need to write small a and capital A in the same program, special care has to be taken so that these two can be represented differently. Say for we write it small a and this we write as capital A. So whenever you write, so SA means small a and CA stands for capital A. First thing is that we need to write a variable. In algebra, you know that lower alphabets A, B, C, D, they are used as constants, and higher alphabets U, V, X, Y, Z, they are treated as variables. But in computer language, only the constants are these and these are the variables. So we first need to assign the value of the variable. How to assign this value? We write the variable name and then we write this sign. I am not talking about I am not saying that this is equal to sign. I put this sign and we write 1. And in the next line, not in the fashion we have written by commas, in the next line we need to write b is equal to 5. Then we want to calculate c. Now the calculation is done in such a way: c is equal to a plus b. So this plus sign stands for the arithmetic addition operation, and the law is that the quantity that you want to calculate, it should be a single quantity, must be written on the left of this sign. This I am saying it equal to sign, but it is not equal to sign, that I will come later. So what we do, we write a single variable on the left, and on the right of the equal to sign we write the expression. Then once the program is compiled, when it comes to this step, it reads the value of a and b and calculates the value of c, and so the value of c now is 6. How to know what he has calculated? We ask the computer to write this star comma c. This write is it is an output statement which asks the program to write the value of c that it has calculated. Now for this purpose the calculation is over. So we must provide an instruction to the computer to stop programming. So this is the logical stop of the program. By stop, it means the program will stop executing, and this is a physical end of the program. See the difference between these two instructions. Here we have written c is a plus b is equal to c, and then afterwards we have assigned the value of a and b and asked the questions what is c. Everybody will give the answer c is 6. But whenever we are providing the same instruction to the computer, first thing is that this step has to be rewritten as c is equal to a plus b. Even if we write this in this step, no value were assigned to the computer about a, no values of a and b were assigned to the computer. So a good compiler will assume a to be 0, b to be 0, so it adds 2 zeros to yield another 0, and that 0 value is assigned to c. And if you now tell the program to write the value of c, it will write 0. So what we have done, in a particular line, what are the quantities required to construct the quantity on the left? This is the quantity that we are going to construct or calculate. It has been put on the left of the equal to sign, and we must be very careful about the fact that everything that appears on the right hand appears on the right hand side has been assigned prior to this line. What we do in here, we know this expression, then comes to the value of a and b. Mentally we go back to this line and calculate c, and then comes to the answer. But here the logic should be straightforward. Before coming to this line, it needs to know the value of a and b value has been provided earlier. So now it can calculate c, and whenever you say that tell me the value of c, it will give you the value of c. One thing, there are 2 stars have been put within the parenthesis. They have the specific use, which I shall come later. Now if you write this on a Fortran editor, then thing is that you need to save it. If If you have opened the file already with a name, then save is sufficient. If not, then you need to go to the save as option and save the file with a name. Say the name is test.f. Say the file name is test.f. Then we need to compile it. On the Force editor, you will find the run option, and within the run option you will have compile command. If you click the compile command, this English type or the high level language will be converted into the machine understandable language, and a file will in general be created, which is test.exe. If you try to run this, then again you go to the run option and execute. If you click on execute program, you will find the output, it is 6.0. This is the basic thing. So what you need to do, let me say summarize. First, open file, then save after writing, then compile, then execute. These are the basic steps needed. Now, two things that I am coming to address is how to name a variable in Fortran. First thing is that, and secondly we come to which are the basic arithmetic operations. First, I think the basic arithmetic operation is very simple, and we write in mathematics we write, and in Fortran a plus b, addition. So this is a plus b, a minus b, subtraction. This is also a minus b. Then ab, this should be written a star b. A divided by b, sorry, this should be written a backslash b. Then a to the power b, this should be written a double star b. These are the 5 basic arithmetic operations that are needed, of which I have used this one in this particular example. Now coming to the how to name a Fortran variable. Then naming a Fortran variable. The variable name must start with an alphabet. It should start with an alphabet, as I have seen that here A, B, C, they are the very simple things. Let us consider that in a particular example we come across alpha. So from keyboard you cannot write alpha, and one should give an appropriate name for alpha. One can write R to represent alpha, but whenever you will try to check the program, it will be very difficult to find that R represents alpha. So the name should be in such given in such a way that if you know the theory, background theory, the variable name will be obvious. So how to write alpha? One writes ALPHA, alpha. Whenever you come across this alpha, it will automatically register to your mind that this variable corresponds to alpha. Say we come to beta 1, beta 2, etc. So then the name should be beta 1, beta 2, etc. But remember that one cannot define a variable as a plus b. You cannot define a variable. This is not a valid technique. Because why? Then either the computer will be in confusion whether it is the addition of two variables or not. That's why such things, this operation cannot appear within the name of a variable. But one can write this one, A_1. This is allowed, but A-1 is not allowed. So the rule for naming a Fortran variable is that the variable name should start with an alphabet and it may contain numerics also. Such a character is called alphanumeric character. Now come to this problem again. If one wants to write a Fortran program which will calculate the sum of 6 and 7, that is A is equal to 6 and B is equal to 7, then the problem will be to come to you need to open the file once again, then you change the value of A and B, then save the file, then again compile the file and then execute. So it's a lengthy process. Instead, we could write it in an alternative way. Let me see how the alternative way could be. The alternative way is that we ask the computer, writing from 7th column onwards, read, again star comma star, whose use will be explained later, A comma B. This comma separates two variables, A and B. So I am instructing the computer the program to read the value of A and B from outside. Then we write C is equal to A plus B. These capital A and small a are equivalent, and so for small and capital B. And then we write if you write this program and save it and compile it and then come to execution, in this program you will get the value of C first. See, you will get the result. But here the cursor will start blinking or continues blinking until you provide the value of A and B. So how to when you come to the execution command, execution line, then you first to provide value of A. Say value of A is 7, then comma value of B 5. As soon as you give the provide the computer the values of A and B, it comes to the second line. Say for example, if one gives the value of A only, it will still be on this line because B has not been supplied. One way of supplying B is on the next line, but this is not a fair way. We have instructed the computer that A and B will be provided along a row and they will be separated by comma. So it is our right way to provide the values in this way. If you write few more characters, say 9, -9, etc., it will not consider these values because the program has been instructed to read two values. It assigns the first numerics to A and second to B, and third onwards are not at all needed to it. So it ignores the extra information provided. But if one provides lesser number of information than that has been instructed, the program will not come to the next line. So these are the Fortran instructions. This is an input statement by which we are instructing the program to read something from outside, and by this we are asking the program to write what it has calculated. So these are the simple logics. We have come to the end of the first lecture, and homework is that write a Fortran program, write a program to calculate A plus B, A minus B, AB, A by B, and A to the power B, of which the first one has been done. And you write the output in a convenient way.